In this segment, we're going to be talking about qualitative and quantitative methods. When you're undertaking a task, you have the option to choose a method, which could be qualitative, it could be quantitative, or it could be somewhere in between. When you're going to select a method to use, you have to consider your purpose, and a key factor in choosing that method will be the availability of the knowledge and data that you have. Oftentimes, real-world data is not available or existing for the types of work that we do as systems engineers. What you need to do then is use artificial data, which means it's proxy data or model-generated data. I also want to mention that in choosing methods, there can also be a social aspect involved. Oftentimes, organizations can have a quantitative bias. They think that qualitative methods are too much like an art rather than a science. So if you're going to choose a qualitative method in that case, you want to justify why you've chosen that method and what its purpose is in the task you're trying to accomplish. We have found in our research that a lot of times individuals and organizations can have loyalty to methods, so they don't even question what's the right method for my purpose. It's more a statement of our organization always uses AHP. It's what our leadership understands. And in some cases, that may be the preferred method. The thing is to understand any risks and limitations you have if you end up using maybe a less than optimal method because it's the right one for your organization. Similarly, we find that individuals and organizations often have loyalty to their modeling tools. For example, they say, we've already made a major investment in the XYZ tool, so we're going to use that one. Obviously, methods and models are very connected, and so it's very important to consider your purpose, what the coupling of those two things is that you're going to employ in your decision making or your task, and to certainly at least understand any limitations that are imposed on you if you've chosen a method or a model given the social aspects. Now let's talk about measurement. Engineering decisions often involve the use of measurement as a means to indicate the degree to which attributes or objectives are achieved by various alternatives. So what is measurement? It's the assignment of numbers to attributes of an artifact. And this is according to some procedure so that certain properties and relations are preserved. Scales of measurement is a topic that's not always as prevalent in engineering as it should be. Scales of measurement refer to the ways in which attributes, variables, and measures are categorized and defined. These scales are fundamental to qualitative and quantitative models and methods, yet frequently we see these misused in practice. The four scales that are used most often in engineering are nominal, ordinal, interval, and ratio. Each one of these scales measures certain properties. They determine appropriate operations. For example, can you only do a count, or could you add or multiply? And they also help determine appropriate use of certain statistical analysis. For example, can you calculate a mean or only a mode? The nominal scale is a categorical scale. It involves the assignment of numbers to individual items according to a class or category. A good example is the assignment of numbers to players on a sports team. There's no numerical significance in a nominal scale. Our second scale, the ordinal scale, involves the assignment of numbers to items to be put in a rank order. The order of the values is significant, but there's really an unknown difference between these values. One example would be something like customer satisfaction, rated on a high, medium, and low scale. There's really no way for us to know that the difference between high and medium is exactly the same as the distance between medium and low. Our third scale is an interval scale. This is a numerical scale. It involves assignment of numbers to items based on a single characteristic. With the ordered scale, there are equal intervals, and there's no true zero. A good example of this might be a temperature scale, such as Fahrenheit degrees. There's no true zero because there is no temperature. There are equal intervals because the difference between 2 degrees and 3 degrees is the same as the distance between 3 degrees and 4 degrees. The fourth scale is the ratio scale. The ratio scale has order, and known difference between values, and it also has absolute zero. This is the only scale you can use for determining equality of ratios. A distance scale is an example of a ratio scale, and the distance from city A to city B is the same, no matter if we're measuring it in miles or we're measuring it in kilometers. Why is it important to know about scales? You want to make sure that you're combining things appropriately. You want to make sure you're manipulating data correctly, interpreting measures correctly, and then communicating appropriate information. For example, you can't calculate a mean score for stakeholder satisfaction because it's an ordinal scale. But you could say that X% of your customers are very satisfied and Y% are very unsatisfied.